Hi everybody. So right now I am on our Unit 1 Day 3 notes, which are starting to talk about the real number system and classifying numbers. Usually when we start classifying numbers, I just kind of remind us how we classify other things too. And one little example that I put on here is like classifying birds. So when we are classifying birds, one type of bird is called like a passerine. And the way this picture works is showing that like the passerine is a bird. It's also considered to be a vertebrate type animal. And then, of course, it's an animal as well. And even if you're not very familiar with birds, you figure dogs are kind of like the same way. Dogs could be broken into like golden retriever, yellow lab, border collie, black lab, chihuahua, like all different types of dogs. But so like all of those specific names, those are all different types of dogs, and then dogs are all considered to be animals. So kind of like that, we also are classifying numbers. So like when I look at this picture, everything in here is considered to be a real number. So all of these are real numbers. But then specifically, we've split this into irrational numbers and rational numbers. And then you're going to notice that the rational numbers are split down even more into integers and whole numbers. And the whole numbers and the whole numbers and the integers are probably the ones that you guys are the most familiar with. They use those a lot, or talk about them a lot in 6th and 7th grade. So you're definitely going to see your whole numbers are numbers like 1, 3, 0, like 1, 2, 3. All of those are whole numbers. Square root of 4 is kind of funny too that that's in there. Especially because over in the irrational numbers, we've got a couple square roots as well. So, and the irrational numbers, they're all kind of out there, but on their own. Sometimes though, I get kids though that are like, well, hey, we just learned about numbers like the square root of 4, and the square root of 4 actually comes out to be 2 because 2 squared is 4. Or 2 times 2 is 4. So you may realize, okay, well, the square root of 4, it makes sense that that's in there because it's 2, and then 2 is a whole number. But then that sometimes raises the question for some people, why is that here, but the other ones are over there? And people might realize, well, they must not come out then to be whole numbers. So these irrational numbers are kind of almost like in their own place. I'm going to highlight them in one color for us. But yeah, so we have all of our irrational numbers over here. And if you keep in mind, we talked before about how 4 was what we called the perfect square, because it was like the square of a whole number. 2 times 2 is 4. If you refer back to the multiplication chart that we had given you guys, we kind of highlighted the fact that like all of the perfect squares are coming on this diagonal. So like 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because that's 2 times 2. 3 is a perfect, or I'm sorry, 9 is a perfect square because 3 times 3 is 9. 16 is 4 times 4. 25 is 5 times 5. 36 is 6 times 6. 49 is 7 times 7, etc. So like we have listed on here 17. You'll notice 17 is not a perfect square because 4 times 4 is 16. 5 times 5 is 25. So we said its value must be somewhere in between 4 and 5 then. But it wouldn't come out to be a whole number then. And kind of the same thing with square root of 2, that's not on there, and neither is 11. So square root 11 again must be somewhere in between 3 and 4 because 11 is between 9 and 16. So if you're still kind of really not sure exactly what that means though, is if I go to my calculator and I try to figure out what the square root of 17 is, I try to find its exact value. Notice that if I put it in my calculator, and I have to hit second, and then I'm gonna hit this button, x squared, because it brings me to the square root, then I can type in the 17. Now in this calculator, if this is the one you're using, when you hit enter, it just brings up the square root of 17 again. I have to hit the approximate symbol to actually get the decimal to come up. But you're going to notice that looks weird. It looks really weird. Some people might even say it's like not normal or irregular because it's so weird. But what you're probably going to notice though is it looks like it's going to go on forever, kind of like pi does. But also though, it's not like you figure if I put in like 1/3, 1/3 is repeating. This number that we just got for the square root of 17, that's not repeating. So I'm going to write down, okay, it's not repeating, but it also goes on forever. So this is not considered to be a repeating decimal, but because it goes on forever, I can't call it terminating either. And those are two of the vocab words we talked a lot about the last couple days was repeating and terminating, and irrational numbers are neither of those things. And if I wanted to check and I kind of take a peek at, okay, well, negative square root of 11 comes out the same way. It looks like it's going on forever. The calculator just doesn't have enough room to show forever. But then also those digits aren't repeating. 3, 1, 6, 6, 2, 4, 7, 9, those don't repeat. So it falls under that same thing we just wrote down. And if I do the square root of 2, It's going to go the same way. It goes 1.41421356. That goes on forever also, and it's not repeating. Huh, interesting. On the other hand, all of these are our rational numbers. Everything in this blue box, all of these are our rational numbers. If I look at some of these, I have 27 divided by 4. And just for the sake of time, I'll do it in the calculator. Okay, 6.75. That one is terminating, which means it does not go on forever. It's terminating. Interesting. If I was to look at, say, -6/7, that one actually looks like, if I kind of kept it going, it looks like it does start repeating. 85714, 857, looks like it is going to repeat. If I put in -0.3 repeating, you might remember that would be the same as 3/9 or 1/3. Okay, that one actually comes out to also look like it's being repeating. I'll tell you guys too, even something like, say, I don't know, 12/99, that would be rational. That one's going to be repeating too. And then some of these other numbers like 4.5, that one's also terminating. So basically what we're seeing here is anything that's going to be rational falls in the category of repeating and terminating. And I hope that makes sense for you guys too, because you figure if irrational, irrational should be the opposite of rational. Kind of like being irregular is the opposite of being regular. So if irrational numbers are not repeating, it makes sense then that rational numbers could be repeating. And then if irrational numbers go on forever, it makes sense that terminating decimals might not have to, which again means that terminating decimals would not have, they wouldn't go on forever, they'd have an end to them. So then when I look at these examples for number 1, number 2, and number 3, number 1, we have the square root of 5. And if you couldn't remember if that was a perfect square or not, if you stuck it in your calculator, that wouldn't be the end of the world. But notice, so that one looks like it's going on forever without any kind of pattern or repeating. So then that should fall into the category more like these. That would be irrational. Again, it's going on forever, but it's not repeating. When I look at -17.84 though, that one ends. It's terminating. So because it ends and then it's terminating, that would be something that we can have then for rational numbers. You figure that's kind of like the 4.5, or we put this in and we got 6.75, that's kind of like those. And I know some people were saying they were afraid because it was negative, but notice we do have negative numbers on the rational side. So it's fine that that's a negative number. It's mainly the fact that it's terminating, which makes it become rational. Now, number 3 looks kind of intimidating, but I know the square root of 81, that's just 9, so then this becomes 9/9, and 9 divided by 9 is 1. And you figure 1 is a whole number, so then that would make this one be rational. And part of the reason why for that too is the number 1 is considered to be terminating because it doesn't go on forever. It has an end to it. You figure it's like 1.0. So that would mean that that one is terminating. Anyway, I hope that this video gave you guys like a quick idea about how rational and irrational numbers work. We are going to talk more about this next week on Monday. Thanks for watching.